So let us start. So we will be solving some of the problems based on equilibrium of forces in 3D. So we learned what is central axis and what is the wrench and what is the pitch of the wrench, right? So in that discussion, right, so what we have learned is G can be expressed as P into R in case of a wrench, in case if R comma G forms a wrench. So in this wrench, right, so G can be expressed as P into R, where P is the wrench, pitch. P is equal to G by R. Now, from this relation, if you take a dot product of R on either sides, so G is equal to PR and G dot R is equal to P is a scalar and R dot R. Then P can be expressed as G into R divided by R into R. So this is a dot product. G dot R is Li plus Mj plus Nk dot product with Xi plus Yj plus Zk. And R dot R is X square plus Y square plus Z square. Now this simplifies to P is equal to Lx plus My plus Nz divided by X square plus Y square plus Z square. So this is how actually you can calculate the pitch of the wrench. Got it? So this is the pitch of the wrench. Now if you back substitute this in this equation, so this is G is equal to PR. Now if you take modulus on either sides, then this is going to be mod G is equal to P is a scalar and mod R, right? So P you can equate to this one, and then modulus of R, if you multiply it here, that is mod G is equal to P is Lx plus My plus Nz divided by X square plus Y square plus Z square, and mod R is again square root of X square plus Y square plus Z square. That means, so this goes by root times the denominator. Then you can express this as mod G is equal to Lx plus My plus Nz divided by square root of X square plus Y square, which is nothing but mod R, right? So if you take it to the other sides, mod of GR is equal, or mod GR into mod G, Lx plus My plus Nz. Got it? So this is the other relation. Got it? So here actually, if you notice, we have taken the dot product of L dot G, which is coming out to be Lx plus My plus Nz. And this actually we have calculated yesterday, Lx plus My plus Nz. So this is, so G dot R. So this actually we have calculated. Now actually in today's relation we have proved that mod G into mod R is equal to Lx plus My plus Nz. What is the difference between this and this? Here dot is there and here only the mod is there. Dot will always constitute a cos theta, right? Here actually we are not talking about the cos theta. Then what is the difference between this relation versus this relation? Here we are not talking anything related to the angle theta. There actually G dot R, we can treat this as mod G into mod R into cos of angle between these two. But this theta equal to 0 in case of a wrench, because G can be expressed as PR. That means theta equal to 0 in between G and R. Hence that cos 0 value is going to be 1. Hence, in case of your wrench, you can straight away multiply these two, which will result into Lx plus My plus Nz. So, except for that, there is no difference between these two. Got it? Understood? So, we can make use of the invariant values. Yesterday, I proved that these two values are invariant irrespective of the base point, whatever you selected. Now, with those invariants, we have calculated the pitch. That means, whatever may be the base point you selected, if you calculate Lx plus My plus Nz divided by x square plus y square plus z square, and that is going to give the pitch of the wrench for that particular system of forces. Got it? Okay, you can note down this. Okay. So, if P equal to 0, then actually what can we infer? So, if the pitch of the wrench is 0, then actually, so yesterday I have explained, if the pitch of the wrench is equal to 0, then it results into a single movement. Sorry, it results into a single force without any movement, right? So, G is equal to PR, then P is equal to G by R. And the same P value actually we proved that P is equal to Lx plus My plus Nz divided by x square plus y square plus z square. So both the relations are for the calculation of P only. If P equal to 0, then actually, so this equation implies that G is equal to 0, and the second equation implies that Lx plus My plus Nz is equal to 0, which is the numerator part of it. That means, if the numerator Lx plus My plus Nz equal to 0, or if G is equal to 0, in both the scenarios, it results into a single force without any moment. So, these are the fundamental understandings, so you should be having it. Got it? So, under the scenario of the wrench, so R is nothing but the resultant force So, under the scenario of wrench, R is called the intensity of the wrench. Intensity of the wrench. And the line of action of R is called the central axis. This is called the central axis. So the importance of the central axis is, so on the central axis, if you take the point as the base point, then actually the resultant system of forces will always leads into a wrench. So that is the importance of the central axis. So we can have the resultant force irrespective of the number of forces. So if there are multiple forces, then actually it always results into a single force and a single moment. And then, but this single force and single moment can be any directions. But if you take the base point as on the central axis, then these two directions of the single moment and the single force, which is the effect of all together, will always be parallel to each other, as long as if you take the base point of consideration on the central axis. Got it? That is the importance of the central axis. So under non-wrench scenarios, we treat that as the action, so line of action of the force only. Under the scenario of wrench, the same line of action of force, we call that as the central axis. Got it? Okay. So now actually you can note down, find the equation of the central axis for a system of non-coplanar forces. So earlier actually for a system of coplanar forces actually we found the line of action of the force. Now actually we will be finding out the line of action of the force for a non-coplanar forces. For a system of non-coplanar forces, under the condition of the wrench, so this is called the equation of the central axis. That is, find the equation of the central axis. Find the equation of the central axis. Got it? So now actually under the scenario of the wrench, right? So G can be expressed as P times of R. And then, okay. So if the base point is taken on the central axis, let us say this is the central axis. Now, if you take the base point as outside the central axis, let us say this is O, then actually it results into a system of forces of magnitude R and a moment G. Now, if you take the base point to the central axis, which is on this particular one, then let us say from this particular origin, this is having a location of x comma y comma z, which is nothing but the central axis. Now, if you take the base point at this location, then actually, so this is going to be O dash, right? So this is going to be O dash, and the resulting force R dash, and the resulting moment is G dash. So if you change the base, the resulting force is R dash and the resulting moment is G dash. And we have already learned that irrespective of the change of the base point, the resultant force is always constant. So irrespective of the axis, whatever you select, irrespective of whatever the base point you select, right? So the resultant force magnitude and direction, it won't change. But the way you look at it is different. And that will be resulting into the form of the moment. That means R can be equal to R dash. So this is at O and this is at O dash. But G is not equal to G dash. G and G dash are not equal because the moments are different. Moments are dependent on the position vector, right? So G dash value is completely different. Now G dash is equal to, we already learned that G minus, so this O dash, this vector actually we called as C. So this C cross the resulting force R, where now actually if you take this as the origin and this is the position of the new base point, which is at a location of x comma y comma z, and this position vector, which is nothing but C, is equal to xi plus yj plus zk. Xi plus yj plus zk is the new position vector where you wanted to consider as the base point. Now why we are considering this base point on this particular line is, this is known to be the central axis where this always results into the pitch. Sorry, this always results into the wrench, right? So under the scenario of wrench, so G dash is equal to P times of R dash. Got it? So when we take this as the base point, we definitely know that this is going to result into a wrench. For the wrench case, G dash is always equal to P times of R dash. And this R dash value and R value is known, which is equal. But G and G dash are not equal, and there is a relation that exists in between these two. G dash is equal to G minus C cross R, where C is equal to xi plus yj plus zk, which is nothing but this position vector C. So this is the position vector. Got it? Now, if you replace those values here, that is G minus xi plus yj plus zk is the position vector C cross xi plus yj plus zk. So these are capital X, capital Y, capital J, which are nothing but the resolved sum of the resolved components along x-axis, sum of the resolved component along y-axis, sum of the resolved component of the forces along the z-axis. So all together we have expressed in this particular format, and where the base point is at a position vector of xi plus yj plus zk with respect to the initial base point where we have considered. And this position vector is nothing but the point on the central axis. Got it? So we wanted to identify the locus of x comma y comma z. So this is nothing but the equation of the central axis for us. Got it? So this actually we are going to simplify it. Got it? Okay. So this is going to be g dash is equal to g minus, so this one I j k x y z, and then capital X, capital Y and capital Z. This mod actually we have to be finding out. Got it? So g dash value you can equate it, and so that you will be able to find out the equation of the central axis. First you note down this. I am going to erase it and further simplify it. Done? Okay. So now actually from here you can note down one more point. G dash actually is known to be equal to P times of R dash, and R dash is equal to R. So this can be equated as P times of R, since R dash equal to R. Now this can be expressed as, this G dash can be expressed as P times of xi plus P times of yj plus P times of zk. Now actually what we will do, this side the I component you will be equating to this I, and the j component you will be equating to j, and k component you will be equating to k. So that is going to be the equation of the central axis, which will give you a relation between x, y, z with the known components of this g and r. Got it? Okay. Fine. Now this side what we have got is Pxi plus Pyj plus Pzk is equal to Li plus Mj plus Nk, which is nothing but the G value, minus Ijk xyz and capital X, capital Y and capital Z. So this value, if I further simplify it, Li plus Mj plus Nk minus I times of yz minus zy minus j times of xz minus zx plus k times of xy minus yx. So if I separate this into the components of I, j, k, so this can be I minus yz plus zy into I plus m minus so this is minus, so if you multiply this, zx minus xz. So this is m minus zx plus xz plus this is j plus n minus yx plus xy into k. Okay, great. So I'm just repeating what I have explained. See this. So here actually what we tried deciding here it is the equation of the central axis. For that what we have done is we have identified a variable point on the central axis with the condition of the base point on the central axis will always result into a range. Now keeping that into mind, so we have identified the relation in case of range G dash is equal to P times of R dash, where G dash is the moments of the forces when the base point is on the central axis and R dash is the equivalent force of all the forces together when the base point is on the central axis. So irrespective of the base point, R dash is equal to R. Hence actually we have used this relation. So to put it into this one, G dash value we know that G minus C cross R. So G minus C cross R actually is the G dash value which we have identified, and then this R dash value is equal to R, and then we have made use of those relations to arrive at this equation. Here the variable point being on the central axis, which is nothing but the locus of all the points which has always results into a range, and that locus is nothing but this equation, and this locus we call as the central axis. Got it? So this we are going to arrive at P is equal to L minus yz plus zy divided by x equal to m minus zx plus xz divided by y is equal to n minus yx plus xy divided by z, and which is equal to P. Actually we have already calculated with the invariant values of Lx plus my plus nz divided by x square plus y square plus z square. Got it? So this is the equation of the central axis. Now actually this equation needs to be remembered, because in the examinations, right, the way questions will be asked is, so they will be giving a set of forces. For that actually he will be asking us to find out the equation of the central axis. Now, but remembering this equation is not a tough task. Why? Because there is a method that we are going to describe now. So that method is always results into, so you have to put one location of x, y, z, which is nothing but the position of the point of action of the force, and the corresponding the component of the forces on the second line, and then the second force x2, y2, z2, and the corresponding x2, y2, z2 is the force components, the second force component. Now if you notice here actually in this relation minus yz plus zy, so for a component of x, so this is going to be yz minus zy like this. It will go in a sequential manner. For y actually xz minus zx, and for z actually xy minus yx. So like this actually it is going to fit into. So if you put it in this format, you will be able to arrive at this equation. Got it? So that's why actually, so this equation needs to be remembered, but it's not tough to remember. Clear? Okay, you can note down this. Done? Okay. So now actually I am going to discuss a little bit details about equation of this straight line in case of 3D. Why? Because that understanding is very much needed for us, because we are always talking about the line of action of the force. So unless we know the line of action unless we know the equation of the line, then actually we cannot understand fully the line of action of the force. Here, so in case of 2D actually we know that it is pretty straightforward and simple. So any straight line equation, you can say that y is equal to mx plus c is the equation of the straight line. But what is the equation of the straight line in case of 3D? Now actually suppose in 3D if I say that this is x and this is y and this is z axis. Now if I draw a line like this, can I say that the equation is y is equal to mx plus c? If I say this y is equal to mx plus c in 3D also, there is a z axis also. Now will it be the same straight line equation? Y is equal to mx plus c? So it's not a straight line equation. Now what is the equation then? This equation represents what shape? Tell me what is the shape of this equation y is equal to mx plus c in 3D. No one? Okay, let me tell you. So this is the equation of the plane. Now why we call this as a plane is, in case of 2D, it is going to be a straight line equation. But the same equation, if you put onto the 3D, then this is going to represent a plane. Why? Because we have introduced a new coordinate z, but we are saying that this equation is independent of z. Because there is no variable z in this particular case. That means this is independent of z. So this is going to be still a straight line, but whatever may be the z value you selected, there actually it is going to be a straight line equation. That means, so in 2D, if I say that this is a straight line equation at z is equal to 0, then because xy plane is nothing but the z is equal to 0 plane. Z is equal to 0 means, let us say this is the z axis, and this z value, if I make it 0, I have drawn a straight line equation like this. Now if I take at z is equal to 1 here, somewhere here actually, so this is the point actually where z is equal to 1. Now this is again a straight line equation like this. And then if I take z is equal to 2, again there is a straight line equation like this. Z is equal to 3, again a straight line equation like this. Now actually, if I take from z is equal to minus infinite to plus infinite, so everywhere or at every minor point actually you will be drawing a straight line there. So all the infinite straight lines together jointed is called a plane. So that's why in a 2D, whatever the shape you talk about, in 3D it is going to be exactly the extension of that. In a 2D, it is a circle x square plus y square is equal to r square. But in a 3D, x square plus y square plus z square is going to be a sphere. So a circle in all the directions. Whatever may be the cross section you take it, it is going to arrive at a circle. An ellipse equation, x square by a square plus y square by b square equal to 1. In 2D, the same thing actually if you put it onto the 3D, x square by a square plus y square by b square plus z square by c square equal to 1, it is going to be ellipsoid. That means whatever may be the direction you cut in, it is going to result into a ellipse. Got it? So that is the extension of that. Now actually the complexity comes when we are talking about this 2D shape of straight line. I wanted to put it into 3D. Then actually how can I do that? So what is the equation of this straight line in case of 3D? I will give a simple straight line equation. Now actually, if I take this equation from the origin, then y is equal to mx is the equation. So m is the slope. But this slope actually, in case of 2D, we have got a slope as a single value. But in case of 3D, as I explained earlier, it cannot serve the purpose. The slope will not serve the purpose in case of 3D. So that slope is divided into 3 different components. Those components are the direction cosines, which will decide, all the 3 values together will decide the direction of the line. But here, one slope is sufficient enough to say that with what angle with respect to the x-axis this line is going. But one angle is not sufficient in case of 3D. You need 3 different angles to identify the direction of the line. Now, those values are alpha, beta, gamma, where alpha is the angle made by the x-axis with respect to the line, and beta is the angle made by the y-axis with respect to the line, and gamma is the angle made by the z-axis with respect to the line. So those 3 angles are independent to each other. So it is not dependent on one on the other. That means every angle is independent. Now all the 3 angles together will decide the direction of the line. That means if I take this equation as, so this is x-axis and this is y-axis and this is z-axis. Now if I draw a line like this, now this is making an angle of alpha with the x-axis. This is making an angle of beta with the z-axis, y-axis, and this is making an angle of z with the gamma with the z-axis. Now these 3 angles I have drawn on a plane, but ideally this line is like this. So if it is like this, then actually it will make an angle of alpha with x-axis. It will make an angle of beta with the y-axis. It makes an angle of gamma with the z-axis like this. Now all the 3 angles are there. Now actually we know that this x value, if it is projected onto the x-axis, this x value is nothing but if it is r cos alpha is the x value. If it is projected onto y, then this y value is nothing but r cos beta. If it is projected onto z-axis, then this is going to be z is equal to r cos gamma. Now the same straight line is represented by 3 different values here. Now the same equation, if I put it into a different format, so R I can write this as x by cos alpha, and the same R I can even write as y by cos beta, and the same R I can write as z by cos gamma. That means if I just write this equation, R is equal to x by cos alpha equal to y by cos beta equal to z by cos gamma, this is going to represent a straight line equation. So this will give the fundamental relation. So x by cos alpha plus y by cos beta plus z by cos gamma, if all the three are equal, then that equation is represented as a straight line equation. So in general, L is usually used for cos alpha, and M is used for cos beta, and N is used for cos gamma. So if these three are the direction cosines, we call to be specific directional cosines. So the equation of this straight line can be shortly represented as x by L is equal to y by M is equal to z by N. So this is the equation of this straight line. This is how we arrived at it. Got it? Understood? Or any questions? Any questions on this? Okay, great. So you can note down this. So y is equal to mx is as equivalent as that of x by alpha is equal to y by, so x by L is equal to y by M is equal to z by N. So both are one and the same. This is in case of 2D, this is in case of 3D. Done? Noted? Okay. Now actually I will try to correlate these two equations so that actually you will get a better understanding why this equation is correct. So we have calculated the line of equation for the line which is passing through the origin. Now actually y is equal to mx is the equation of the straight line in case of 2D. Now the same equation what we have got in case of 3D is x by L is equal to y by M is equal to z by N. Now if I extend this equation to consider only for 2D, if I consider this only for 2D, then it is going to be x by L is equal to y by M. Now this L is cos alpha and M is cos beta, or to be specific, angle made by the line with x-axis, and this is angle made by the line with y-axis. Now if there is nothing like z-axis, then obviously this alpha and beta are interrelated to each other, because this is x-axis and this is y-axis. If there is no z-axis, then actually the only way of line is this one. If this is alpha and this is beta, then the relation between these two is alpha plus beta is equal to pi by 2, or beta is equal to pi by 2 minus alpha, where alpha is this one. Now if you put it in this equation, that is x by cos alpha is equal to y by cos pi by 2 minus alpha. Now x by cos alpha is equal to y by sin alpha, or y is equal to sin alpha by cos alpha into x, or y is equal to x tan alpha, or y is equal to mx. Got it? Understood? So this is how actually you can simply correlate. So whatever the equation we have got is for the equation of the straight line when it is passing through the origin. But a little complexity comes when you try to find out the equation of this straight line when it is not passing through origin. Now actually you just note down this, we are going to discuss that as well. Done? Okay. So now actually there is something called direction ratios. If A comma B comma C are said to be direction ratios, if A is directly proportional to cos alpha and B is directly proportional to cos beta and C is directly proportional to cos gamma. So if this is the case, then actually we call these are the direction ratios. Now we know that X is equal to R cos alpha, or cos alpha equal to X by R, and cos beta equal to Y by R, and cos gamma is equal to Z by R. Now these things actually you can simply say as long as the line is passing through the origin. But what if the line is passing through other point? So this is x-axis and this is y-axis and this is z-axis. Now if the line is like this, if this is the line, and let us say this point is x1 comma y1 comma z1 is this point, and this point is x2 comma y2 comma z2, then this will also definitely make certain angle with x-axis, and it will make an angle with y-axis, and it will make with an angle of z-axis. Now those values are anyway equal as and when, suppose if I will take this straight line equation, put it in this place, that is from the origin. So exactly parallel lines, then whatever the angle made with x-axis is alpha, and this is beta, and this is gamma. Now the same thing, if you extend this line, this is going to make an angle of alpha with x-axis, and this is going to make an angle of beta with the y-axis, and this is going to make an angle of gamma with the z-axis. Now angles wise, did you see any difference between these two? So there is no difference between these two as long as the angles are considered. But only thing that is different is it is located at a different location. And then this value is r, which is nothing but the length of the vector. Now if I complete this, then this value is r, and this value is x, and this value is y, and this value is z. So this value projected onto this is z. Now obviously this value, right, what is this length between these two? With respect to this coordinate system, this position is x1, y1, z1, and this position is x2, y2, z2. Now what is this length between these two? The starting point, ending point on the x-axis. Make it fast. So this is x2 minus x1. And similarly, this height is nothing but y2 minus y1. And similarly, this z2, this length is z2 minus z1. Now, if you take this as the angle and this as the r, this is as if like taking this as the origin. If I consider the origin from the x1, y1, z1, if I consider this as the origin, then x2, y2, z2 are the new point of consideration for us. That means if I take this length x2 minus x1 is proportional to, or actually this can be equated to r times of cos alpha, because alpha is same in either case. So r times of cos alpha is nothing but x2 minus x1, or cos alpha equal to x2 minus x1 divided by x2 minus x1 divided by r. Similarly, cos beta equal to y2 minus y1 divided by r, and cos gamma is equal to z2 minus z1 divided by r. So these ABC values, whatever I am talking about, which are nothing but the direction cosines, these values are proportional to, if r is constant, because r is there in all the aspects, then cos alpha is proportional to x2 minus x1, and cos beta is proportional to y2 minus y1, and cos gamma is proportional to z2 minus z1, and these values are called direction ratios. Got it? So if these are proportional, then actually this x2 minus x1, y2 minus y1, and z2 minus z1 are called as the direction ratios. Got it? So the information can be given in two different formats. For a straight line equation, which is nothing but the line of action of the force. So one is the point of application of the force. In this particular case, the point of application of the force is x1, y1, z1, and the line of action of the force will be given as in terms of the direction cosines cos alpha, cos beta, and cos gamma. Got it? So if he talks about the direction ratios, then actually these are the direction ratios. These are the direction cosines cos alpha, cos beta, cos gamma. That is the difference. So this is the equation of the straight line when it is passing through origin, and these are actually coming into picture when the equation is not passing through the origin. Got it? So the same equation can be extended to as if like the origin is shifted from this location to this location, which is at, let us say, x1, y1, z1. Then the equation of the straight line is going to be, if you take this as the origin and this length can be treated as x2 minus x1. First you note down this, I am going to write that equation. So the equation of the straight line passing through a point alpha comma beta is x minus alpha by L is equal to y minus beta by M is equal to z minus gamma by N, where alpha comma beta comma gamma, these are not the angles. Maybe actually might confuse. I call this as x1, y1, z1. x1, y1, z1 is the point of application of the force. Point of application of the force, where the line of action of the force passes through. And L comma M comma N are the direction cosines. So as and when actually if you see this location, you can straight away say that the point of application of the force is x1 comma y1 comma z1, and the direction of the force is going to be L comma M comma N. So which will give the cos alpha, cos beta, cos gamma values. So these are the direction cosines. That means if there is a force of P that is acting at one particular location, let us say this is the force that is acting like this. So this is a force vector of magnitude P, and the direction cosines are L comma M comma N, and the location of the application of the force is alpha comma beta comma gamma. Then this force can be treated as x minus alpha by L is equal to y minus beta by M is equal to z minus gamma by N. This is the line of action of the force. So this is the line of action of the force. Now actually if you want to find out the component of the force along x-axis, y-axis and z-axis, you are interested in these directional cosines, because that is the line of action of the force. So this L, M, N values will decide the components of x, y, z. That means if this total force is P, then the force component Fx is equal to PL and Fy is equal to PM. and Fz is equal to Pn. So these are the force component along x-axis, y-axis and z-axis, or in other words x1, y1 and z1. So this is for one force. Similarly, if there is one more force Q that is acting at a different location, then you can divide into x component, y component, z component with the help of their direction cosines currently, right? So you will be able to find out the equivalent force along x-axis, y-axis and z-axis with the help of direction cosines. But this alpha, beta, gamma will give the point of application of the force. So this will be helpful in finding out the position vector from the origin, which is nothing but r for us. So this position vector is needed for the calculation of the pitch or the action of the line of action of the force, which is nothing but the central axis. Got it? Understood? Do you have any questions on this direction cosines and direction ratios? Because we will be rigorously using these concepts when we are solving the problems. Got it? So along with the concepts, whatever we have learned, with this application of the basics, so you will be solving the problems. Okay, so you can note down this. So note down on problem. A single force is equivalent to component forces. A single force is equivalent to component forces. X comma y comma z along the axis of coordinates. Along the axis of the coordinates. And two couples L comma M comma N, and two couples L comma M comma N about these axes. About these axes. Prove that the magnitude of the single force is, prove that the magnitude of the single force is x square plus y square plus z square under root, and the equations to its line of action are its line of action are yz minus zy divided by L is equal to zx minus xz divided by M is equal to xy minus yx divided by N is equal to 1. Got it? So he asked us to find out the line of action of the forces is like this. Try to understand this problem statement clearly. Done? Okay. See this. A single force is equivalent to component forces x comma y comma z along the axis of coordinates, and two couples L comma M comma N about these axes. Prove that the magnitude of the single force is square root of x square plus y square plus z square, and the equation to its line of action of the force is L. So this equation. Now actually what he is talking about is this system of forces actually is resulting into a single force. That means no moment. If there is no moment, then actually, obviously, P will be 0, which is nothing but the pitch of the wrench is going to be 0. If P equal to 0, then Lx plus My plus Nz is equal to 0, because P is equal to Lx plus My plus Nz by x square plus y square plus z square equal to 0. It implies that Lx plus My plus Nz is equal to 0. Now, so this P value is 0 in case if it results into a single force. Now, the equation of the central axis or equation of the line of the action of the force. So this one actually we have already derived. That equation is L minus yz plus zy divided by x is equal to m minus zx minus x plus xz divided by n is equal to n minus xy plus yx divided by n, and this value is equal to the P value, which is nothing but Lx plus My plus Nz. Now, this equation, if it results into a single force, then obviously P value is going to be 0. So, if P equal to 0, then actually this is equal to 0. Now, the denominator whatever is there, right? So, it is going to multiply with 0. Hence, what we left over is this L minus yz plus zy is equal to m minus zx plus xz is equal to n minus xy plus yx. So these three are equal. Now if these three are equal, then actually I can say that so this value is equal to 0. So because P equal to 0. If that is equal to 0, for each equation you can calculate this value yz minus zy y capital Z minus z capital Y divided by L equal to 1. Similarly, if you take the second equation to 0, then zx minus xz divided by m is equal to 1. Similarly, this equation xy minus yx divided by n equal to 1. So, this equation, what you have got it here, so the same equation will result in as long as if P equal to 0, which is the condition for the system to have a single force without any movement. Got it? Understood or not? Any questions? Okay. So this is how actually you will be solving. So in tomorrow's class, I am going to explain in detail. So when there are multiple forces, 3-4 forces are there, then how to find out this pitch or the central axis equation. So that will be a little lengthier problems. Maybe we will try to solve 2 problems. So based on that, you will get a complete understanding. So after that, we will be done with it. So tomorrow we will be done with equations of, equilibrium of forces in case of 3D. So there are 2 more topics that are left over. That is virtual work and another is the stability of equilibrium. These are the 2 important concepts that are going to be discussed in detail. So with the statics. With that, we are done with the statics. Only dynamics part will be left over. Got it? Yeah. So I'm closing the class for today. Thank you. Good night.